Okay, we're going to do an example, taking an angle and finding a reference angle, which is a reflection back into the first quadrant, and then using the reference angle and its sine and cosine value to help you figure out the sine and cosine value of the original angle, which would be the one we started with. So first of all, in this first example, let's use t equals 5 pi over 6. So that's our starting angle. That is not in the first quadrant. Let's draw a unit circle and plot 5 pi over 6, the angle, in standard position and determine where it is going to terminate. So here's our unit circle, 5 pi over 6. Well, over here is pi, right? There's pi. Here's 0 for reference. We're going to take pi and divide it into 6, okay? So because we're talking about sixths. This is all about fractions here. So take pi, just divide it into sixths. There's half, so I want to divide each of these into thirds, right? There's thirds. So now 5/6 is going to start, we're going to start from our, positive x-axis here in standard position. We're going to measure 5/6. 1, 2, 3, 4, 5. 5/6 would be right there. So there's our terminal side. So that's 5 pi over 6. So the point on the unit circle that we're dealing with here is this one. Okay. To find the reference angle, you've got to think about reflecting that point back into the first quadrant. So reflecting it over the axes. In this case, we don't need to reflect over the x-axis because we're already above the x-axis. We've just got to reflect over here across the y-axis, bringing us back over to this point. Okay, and that's the reference angle. So that's the sort of spatial reasoning way of figuring out the reference angle. In this case, it equals that point there, which is 1/3, right? From 5/3, you reflect back and you get to 1/3. So that's pi over 3. Okay. You can also find the reference angle by doing subtracting or adding to pi. So remember, try pi minus t or pi plus t. Or if that doesn't work, you can try other multiples of pi plus or minus t until you get some angle which is in the first quadrant. So in this case, if we try pi minus t, let's see, let's do that down, let's do that over here. Pi minus 5 pi over 6, okay? That's gonna be, let's get a common denominator to do that subtraction. 6 pi over 6 minus 5 pi over 6. And then 6 pi minus 5 pi is going to be 1 pi, and then that's over 6. Oh, haha, silly me. I made a mistake here. If you caught that mistake right away, good on you. But if you didn't, that's okay. I didn't either. Let's go back here. This was 1/3 of, not 1/3 of pi. This was 1/3 of pi over 2. Silly. Okay, so 1, 2, 3, 4, 5, 6. This is 1/6 of pi. So this is supposed to be, let's write it again, pi over 6. There we go. And we got the same answer from our subtracting from pi strategy. Sorry about that mistake. A little embarrassed about that, but that's okay. So now that we've found our reference angle, now we can take this information. For the reference angle, let's stick with red here to color code things. For the reference angle, cosine of pi over 6 and sine of pi over 6, you can get these values, the exact values for cosine and sine, by thinking back to what we learned about with the special triangle. So pi over 6 is 30 degrees. So we're talking about cosine and sine of 30 degrees. If you haven't memorized those values, that's okay. I'm going to show you a full unit circle and walk you through some mnemonics for memorizing all these things later. But these values, I'm just jogging your memory of how we know these values. It's from the special triangles. These values are the square root of 3 over 2 and 1/2. Okay, that's the x coordinate and the y coordinate. So this point right here is square root of 3 over 2, comma 1/2. Okay. Now, what we know about the all students take calculus is that in the second quadrant, all students, sine is the only trig function in the second quadrant that's positive. So we've got to make the the cosine value negative. So over here, when we reflect back to our 5 pi over 6, it's going to be negative square root of 3 over 2, comma 1/2. So this gives us cosine of 5 pi over 6 is going to be negative square root of 3 over 2, and sine of 5 pi over 6 is still equal to positive 1/2. And those are the answers we were looking for. Okay. So this example demonstrates how you can take an angle, which is somewhere on the circle, reflect it back over to the first quadrant, find the reference angle in the first quadrant, and then use your memorized values to get the sine and cosine and sine value for that specific angle. This is assuming it's an angle that we've memorized. Okay, most angles we don't know, but if it's one of the special angles, you can get the exact values of sine and cosine, and then just make an adjustment to the sines according to which quadrant your original angle was in, and then get the exact values of cosine and sine for that original angle. Okay, so that's the process, right? It sounds like a long and complicated process, but once you've practiced it, it's actually super intuitive, and you can practically do it in your head, as if you just draw some circles and do a little spatial reasoning. Okay, so there's one example. I'm going to do a second example. I'm not going to do the entire thing. For the second example, I'm just going to find a reference angle, because that part is kind of the main point of this video, I guess. So let's just find reference angle. And let's take t equals negative 7 pi over 12. So first let's find negative 7 pi over 12 on the unit circle. So first of all, remember, 0 is here, pi is here. Negative means we're going to be measuring down, okay, from the positive x-axis. And we've got to divide our pi into 12s. So this is going to be 6. Let's do thirds again. There's thirds. So 1, 2, 3, 4, 5, 6. And now let's divide that in half again to get twelfths. There we go. Dividing each of those segments in half. Okay, so I cut it in half, cut the halves into thirds, cut the thirds, which give us sixths, and then cut all those sixths in half to give us twelfths. Okay, so negative 7. Here's negative 1, 2, 3, 4, 5, 6, 7. There we go, right there. That is the terminal point for negative 7 twelfths of pi, right? Measuring down. So what we've got to do now is bounce, right? Bounce it back. So we're going to bounce over here across. We'll cross over the y coordinate, sorry, the y-axis from 7. It's going to flip back over here to 5, negative 5 pi over 12, and then if we reflect up over the x-axis, if that was negative 5 pi over 12, this up here is going to have to be positive 5 pi over 12. This is going to be, again, twelfths. Let me draw all the twelfths in. There we go. So counting up, 1, 2, 3, 4, 5. So right there, there's our reference angle. That's going to be 5 pi over 12. And if we had some tools to figure out the exact cosine and sine values of 5 pi over 12, then we could take those nut values, and then we'd have to make both of them negative, right? Whatever the x and y are over here, back on this side, it's back in the third quadrant, it's negative x, negative y. Make them both negative, and those would be the cosine and sine values for negative 7 pi over 12. By the way, we are going to figure out how to get the exact cosine and sine values for 5 pi over 12. It's going to involve some trigonometric identities. We're not going to do it until a future chapter, but just so you know, that is coming up. So eventually you'll be able to complete this problem.